All right. Good morning, everyone. Today is Friday, October the 8th. We are on day 2 of circles. Also, I don't know if any of you noticed, but in your Class Connect schedule, I do have day 3 of circles scheduled for this afternoon at 12:30. If you can make it, great. If you can't, you can watch it. You can even watch it next week. So I will be absent on Tuesday and Wednesday next week. So you can use Tuesday to watch the recording that I'm doing today at 12:30, and then you can do the quiz. So I won't put zeros in for the quizzes for circles or ellipses until after fall break, because if you do decide to wait until Tuesday next week to watch day 3 of circles and then take the quiz, that's fine. So the plan is right now, day 2 of circles, afternoon, day 3 of circles, Monday, day 1 of ellipses, and then Monday afternoon at probably 12:30, I will be doing day 2 of ellipses. That way I don't miss any live sessions that some of you appreciate and watch, or the recordings. Oh, no problem. Yeah, if your brain doesn't work as quickly as others, I totally get it. No problem. I am also not a very quick person when it comes to working out stuff. All right, so let's do volunteers for all 4 of these. So we'll let me just label these as 1, 2, 3, 4. Hope my pen works this morning. So we'll call this number 1. Nope, it's not working. It's not working. All right, numbers. So let me make sure I have permissions. I always forget to check my pen in the morning when I turn on my computer. So I usually don't restart my computer, and then whatever happens over the night, it just stops working. All right, so I'm going to let all of you who are here right now in chat decide. There's 9 of you. Decide who's going to write the answers for these 4, and as you do that, I am going to restart my computer. No, you can't hear me? Oh, you can hear me. Yes, you can? Oh, now you can. Okay. All right. Good. All right. Good. All right. So it looks like you all figured it out why my computer restarted. Just seeing if you all split it up, and it looks like you did. Wow. I'm actually really impressed that I have four people. I would have thought if I was a betting man, I would have bet that it would have been two people doing all four problems, but you all surprised me. Nice job. All right, so we got 0, radius of 2, 7, -7, radius of 4, -1, -4, radical 5. Ooh, nice job. And then 2, 5, and then 2 radical 5. Nice job, everyone. I agree with all those answers. Very good. Excellent job. All right, so let's jump in today. Today's kind of a long lesson. I have a total of 17 slides, this being the first one. Um, Not every slide is going to take like forever to go through. Like, oh, here's slide 2 of 17. So writing equations of circles. Paper, pencil, of course. Complete the square. I don't think we use that quite yet today. I know. I feel like every day I tell you we're going to use it next day, next day. Well, actually, we are. Okay, we're definitely. If we don't use complete the square today, we're definitely using it this afternoon for day 3. I promise you. If we don't use it today. All right. This one. So I kind of feel like these probably don't need me to spend the 5 or 10 minutes to go through these. Knowing what we know yesterday and doing the bell work, I really trust that most of you can probably read these word problems and create the equation of the circle and, of course, simplify it. So everyone try the first one here. What is the equation of a circle whose center is 0, comma, -2 and radius is 3? So let me give you all I think a minute is more than enough. Maybe it would take me probably a minute just to write down the question, but I write so slow. My handwriting looks like cave drawings. I go back to read my own handwriting sometimes, and I have no idea what I write. It's actually quite terrible. So if I want to read what I write, I have to write very slow. All right, 1 minute, ready to go. All right, when you are done, give me a green check. So when you're done with the first problem, give me a green check so I know that you are ready to talk about it. And if you are done with the first one, I'm still waiting for a few more people. If you're done with the first one, feel free to work on the second problem on this page to kind of get a head start. All right, looks like everyone is ready. All right, so in chat, what is the final answer? So don't hit enter yet, please. Don't hit enter yet. Some people type slow, but I want you to type it in the chat box and wait. So, what is your final answer? Type it in the chat box. The final answer, simplified, all that good stuff. I'm gonna give you another few more seconds, get everyone to type it in. All right, count of three. Everyone hit enter. 1, 2, 3, go. Ooh. Ooh. So looks like everyone got it right or almost got it right. So again, make sure you simplify. Make sure you simplify. So I see one of you did not simplify. You're not wrong. You're just not finished. So dun dun dun. Yeah, everything it looks good. Everyone who responded in chat, it looks really good. So yeah, that was the first step, right? Setting it up. All we do is we plug in your. Remember, this is H, this is K, and we plug those into H and K, and that's what I did. There's H, there's K, and I saw someone in chat write this as their answer. So we have to go one step further. Remember, a negative and a negative make it a positive, so that's why it's a plus. And 3 squared, of course, is 9. But on your paper, I really hope that all of you have this step written down before writing your final answer. I know I understand some of you probably didn't do this step, and that's also okay. But it is possible to make mistakes if the less work you show, the bigger the chance of making a mistake. So nice job, everyone. Looks like everyone who wrote in chat got that correct. All right. The second one on this page, I'm going to give all of you about the same amount of time, about a minute. Give me a green check when you are finished with the second one on this page. And I will wait till everyone is done. And when you're done, make sure all of you get out your formulas that we did the first 2 days of Unit 3. We had these 2 lessons with formulas. You might want to get those formulas out. All right, so everyone go ahead and type in your answer. I'll give you a moment to type it in before you hit enter. All right, count of 3. Let's hit enter. 1, 2, 3, go. Ooh, everyone got equals 12. Nice job. I think we all learned our lessons yesterday, right? About squaring a number like that, right? Nice job. And again, you all got to make sure that you simplify. So I see one of you did not simplify your final answer. Dun dun dun. Yeah, make sure you simplify. If you, let's say on a TGA, if you did not write that as your final answer, I would mark it wrong. And make sure you simplify completely. So if you stopped here, you got no credit. If you stopped here, you got no credit. You would have to have actually gone all the way and simplify. Okay, nice job, everyone. Now for the fun stuff. All right. What is the equation of a circle whose endpoints of diameter is -3, -2 and 5, 6? So this is a fun word problem. You know, we need to create the equation of a circle, right? We need to create the equation of a circle, and I give you the endpoints of the diameter. Any thoughts? How can we approach this problem? Feel free to take the mic and give me your thoughts, or in chat. It doesn't matter. All right. So Noah says distance formula and midpoint formula. So let's do this. Why the midpoint formula, Noah, or anybody? Why would the midpoint formula be good to use in this situation? And again, guys, don't be shy. Take the mic. And even when I'm talking, if I'm saying stuff and I don't see a chat message, feel free to jump on mic and just interrupt me. I don't take offense to it. So Natasha says we use the midpoint formula because it's the center. Yeah, that kind of makes sense. If you have a circle, so I'm going to draw a picture here now that my touchscreen works. Let's draw my circle. Got a circle, right? And then I'm going to draw a diameter. So I'm going to do the best I can. Hopefully that's a diameter, so we can kind of see that, right? And then let's do, so I give you 2 endpoints. And I give you, let's say, this one, and I give you this one, right? Do a little bigger on the bolding here. There we go. So I give you those endpoints of that diameter. If you use the midpoint formula, you're gonna find the center of your circle. That makes sense. So that takes care of that piece. And then why do we use the distance formula? What will that do? So looks like Noah says to find the diameter, which we can use to find the radius. So if you know the length of the diameter, how do we use that to find the radius? Anybody, as we got nine of you in chat, and all 9 of you should know the answer to my question if you took geometry. So if you use the distance formula to find the length of diameter, how do we use that to find the radius? Lizeth says we could use the distance formula to find the distance from the center to one endpoint, and that is also true. So there's 2 ways to approach it. You can find the distance of what Lizeth said, center to an endpoint, or you can use the distance to find the length of the diameter. And if you know the length of the diameter, how can we find the radius? Divide by 2. Yeah, guys, the radius is half of the diameter. We should all know that from geometry. Is it still early for a lot of you? You're just waking up? Yeah, so we're going to use those formulas now. I'd like all of you to quickly find those, and I'm going to do the midpoint formula first as well. Everyone quickly do that. I'm going to give you 30 seconds to find the midpoint. Guys, try to be one step ahead of me. Like when we talk about using the midpoint distance formula, try to work ahead at least a little bit. It is kind of a long lesson, I feel like. So, guys, if you feel like I'm going kind of fast today, don't forget you can always go back and watch the recording and pause as needed to go through this. Unfortunately, I have to maintain a certain pace in order to get through most of the material. If I didn't have to teach a class after this one, I would honestly go over time every day by probably 15 to sometimes 30 minutes. Shame on me, right? All right. Anybody have the midpoints? What the coordinate is? Anybody in chat? 1, 2. 1, 2. Now I totally get that. Maybe a lot of you don't have that answer yet because you're still plugging it in, you're still working it out. But there's the work. It is 1, 2. Next, we're going to use the distance formula. Now, you have a choice. So really, if you know the midpoint, it might be you might just want to use the midpoint to find the distance from the midpoint to one of your endpoints. It doesn't matter. So you could do it that way. The work that I have on this screen, I use the original problem. I use my 2 endpoints. I do that distance, and then I cut it in half. And the reason why I do that is because what if you made a mistake in your midpoint and this coordinate was wrong? If your coordinate is wrong for your midpoint, your distance, your radius, will be also wrong, even though that work might be right. So it's up to you. It'll work just fine if your midpoint's correct. But I use the diameter points every time, and I just cut it in half. That's just as easy. So, all right, 30 seconds. See if you can find that distance formula. Answer. That is. All right, so my question is this. So be careful what answer you put in the chat box. Based on however you approached doing this second part, I want you to give me what the radius is. I don't want the distance that you found. I want the radius of this circle. So go ahead and put that. What is the radius of this circle? So we got 4 radical 2. And let me see if that's correct. All right, 4 radical 2 is correct. Yeah, if you got 4 radical 2 as your radius, you did it correctly. Here's the work for the distance, which we all should know how to do, whether you do it really quick or really fast or really slow. It doesn't really matter as long as you get it done. There's my work. And then, yeah, so like when I do my work, guys, I really hope none of you are typing this in and hitting enter. All of you should be doing this by hand. Like we're going to have this becomes 5 plus 3 is 8. 6 plus 2 is 8. And then I would, if you don't, everyone should know what 8 squared is. But if you don't know what, a number squared is, you type in the number squared, hit enter, get the number squared, hit enter, get the number. Then I would do 64 plus 64, and I would hit enter to get 128. And then at this point, this is where I would type in the square root of 128 on my Casio FX 300 series or 115 series. I would hit enter, and then my calculator would tell me the answer is 8 radical 2. And then to find the radius, remember this is the distance from endpoint to endpoint, so we would have to cut that in half. And that's why the answer is 4 radical 2. All right, then from here, we know the midpoint. We know that, remember, the midpoint is the center of your circle, and we know the radius. So everyone very quickly create the equation of your circle and simplify. I'm going to give all of you 30 more seconds to do that. Right. All right, final answer. I'm just going to show it just to save time. But there's your setup. And then there's my work that I do by hand. And then there's my final answer. You could have easily, if you're typing parentheses 4 radical 2 in parentheses and then squared and hitting enter to get 32, that's fine. That's fine. But that is the final answer. All right. So hopefully now seeing one of these, you understand how to use these formulas, the midpoint and the distance, to find your center of your circle and also the radius. All right, let's go on. So I'm going to skip this. If I have time at the end of class, like we have about a half hour left. I will come back to this if we have time, but just keep this problem in the back of your head, the one we just did, because this is the practice problem I would like you all to do. But let's go on to this problem here. All right, what is the equation of a circle whose center is 5, 4 and is tangent to the x-axis? Tangent to the x-axis. What does it mean to be tangent to something? Yeah, touching. It means it's like just touching it, right? All right. So these kind of require you to do a rough sketch on your paper. So if I was going to do like a little rough sketch, oops, let me use a different boldness of my graph. So let's do just a little rough sketch. And then I'm going to plot. So we know the center. The center is 5, 4. So which quadrant is our center in? Which quadrant? Yeah, it's in quadrant number 1. And if you forgot the naming of quadrants, let me just quickly point to the quadrants as a little refresher. This is quadrant 1, and then we go counterclockwise. This is quadrant 2, then quadrant 3, and then quadrant 4. So 5, 4 is in quadrant number 1. So I'm just going to do a little point over here. So, that point right there, that's 5, 4. All right. Then, so we know where the center is, and then it says the tangent is tangent to the x-axis. So what I'm going to do is I'm going to just write over my x-axis to emphasize that x-axis. So if this is my x-axis, right here. So I can see that in my green pen. So it's tangent to that x-axis. So I'm just going to do a little dashed line, just a little dash. Oh, that's not dashed. Dashed. Okay, dashed line. So it is tangent to the x-axis right there. So that means my circle, it does that. That's what it's telling us. It's tangent to the x-axis. So from the center, we have to draw a line, and tangent points make a right angle. So, just showing that. So when you're given a problem like this and it's saying it's tangent to something, do a rough sketch, plot the point in the quadrant where it's located. It doesn't have to be exact. So I didn't do tick marks to show this is 5, 4. I just did a point over here. It's tangent to the x-axis. So I highlighted my x-axis, and then from my midpoint, my center, I did a dashed line down to that tangent line, just to show it's a right angle. And that tells us that's where the circle, the endpoint, touches. So I just kind of circle my my center. So that's my rough sketch. Now it's let me see what the answer is. Yeah, so this is actually, so my sketch is not even close. Well, it's close, but it's not close. It's not the answer. And I do have the answer graphed on this page once I show you. But this gives us an idea of what's going on. All right. So we know the center. We know H and K. We just need to know the radius. So based on this rough sketch, and we go straight down to the endpoint, how can I find, or do you have any ideas of how we could find the radius of the circle? So notice the radius is 4. How did you find the radius? Like, what was your approach to that? You are correct. Yeah, of course. Use the mic.
So I looked at the center, and so we know that the circle is tangent to the x-axis. So that means that it's touching the x-axis, which means one point on the circle would have a y coordinate of 0. And so we can see that the center is 5, 4, which means that it's 4 units away from the x-axis, and therefore the radius is also 4 units.
Perfect. Perfect. Couldn't say it better myself. So this coordinate right here is 5, 4. Remember, this is, like he was saying, this is the y value. And then this right here, well, because it goes straight down, the x value is the same. I'm just going to put a 5 there. And the y value is, well, it's on the x-axis, so it's 0, right? So from 0 to 4 is 4 units. So because of just making that observation, he says, well, the radius is 4. And yeah, that's correct. So drawing a sketch like this really helps to see that. You could also use the you could also use the so I should have actually called this a vertex point, not a radius point. I need to fix that in my lesson. Yeah, it's a vertex point, not a radius point. I don't know why I did that. But you could use the distance formula, but you really don't have to because you can just count from the axis over to, whatever, we're talking about y. The y direction changes, the x doesn't. So from 0 to 4 is 4 units, but you could just go ahead and plug those 2 points into the distance formula to solve and get the same thing. It works probably a little overkill for this if you kind of rationalize it like Noah did. But we get the same thing. The radius is 4 from the vertex point that's tangent to the x-axis, and then the center. And then you just plug everything in and simplify. So the problem, the problem when you look at it seems a lot harder than it really is until you kind of break it down and do a little sketch. In Desmos, that's what it looked like. Fortunately, I can't. I could drag multiple items on the screen and hit delete, but I can't. I gotta click one at a time. Neuro is such trash. All right, good enough. So that's what it actually looks like when you graph it in Desmos. You have the center. This is a vertex point, not the radius point. I don't know why I called that. Vertex point, and the distance you can even count 1, 2, 3, 4. You don't have to use the distance formula. All right, how's everyone feel about this problem going through it? Pretty good? Good. Good to hear. All right, so we are going to skip my example on that. How much time we got? Let me come back to this one too. So this one has a center of -2, -6. And actually, let's do it real quick. Let's everyone do this. I'm gonna give everyone quick. Let's do it in. I really think that you all can do it in 2.5 minutes. So let's do that, and then hopefully most of you are done. But yeah, 2.5 minutes. Ready to go. All right, anybody in chat want to put their final answer if you're done with it? I know that was pretty quick. Anybody have a final answer? X plus 2 squared plus y plus 6 squared equals 4. That sounds right. Let's take a look. It is 4, yes. All right, so for this one, this is what the graph looks like. So you want to plot that center, and then you can just remember so this is tangent to the y-axis. So you want to emphasize this is the y-axis. So from the center, you want to go to the right. So on your test, this is where people are going to miss this problem because they're going to maybe not do practice problems and just be in the habit of going to the x-axis, but this is tangent to the y-axis. And you have to know the difference between the x-axis and the y-axis. You should definitely know that. So from the center, we go to the y-axis. So we count. So your x value is one that changes. The y value is still going to be the same. So the y value is still 6, but we go from x equals 0 to x equals -2. So remember, distance is always positive. So from 0 to -2, that's a distance of 2 units. From 0 to 2. And really, that's all you need to know. You don't have to do the distance formula. I did, but I think doing it this way is probably not the best way. Doing a rough sketch and then identifying, are we traveling in the x direction or in the y direction? In this case, we're traveling in the x direction. So from the axis to the center of the circle, the x value is 2 units. So however you want to approach it. And then you just plug everything in and get the answer. Yeah. All right, so let's get to the hardest problem of the lesson. Ooh. This one's fun. But again, the more work you show, you might be able to see what's going on. So what is the equation of a circle whose center lies on the line y equals 2x plus 1 and is tangent to the y-axis at 0, 7? All right, ideas on how we can approach this problem. Ideas. So now it says sketch y equals 2x plus 1. Yeah, let's go ahead and do that. Let's do some points here. Remember our basic graphing, the y-intercept is at +1. So let's do a little point at +1. Right there. And then our slope is 2. So it's 2, remember, rise over run, 2 over 1, so up 2 over 1, so up 2 over 1, up 2 over 1, up 2 over 1, and so forth. And then I'm just going to draw a line through some of my points. Let's see. All right. And then, of course, we graph something. Don't forget your arrows. A lot of you didn't put arrows on your graphs on Unit 1 TGA. I didn't mark it wrong. I just was wondering why you don't put arrows, because it does go on forever. All right. Next, it says that it is tangent to 0, 7. What we want to do is on the graph, go to 0, 7 and plot a point. 1, 2, 3, 4, 5, 6, 7. All right. So that is tangent. This one's pretty easy. If you graph it accurately, like I did, well, accurate for the most part, it's pretty easy to see what the answer is going to be. But remember, the center is on that line, and it's tangent to the y-axis at 0, 7. So what I could do is I'm going to draw a dashed line from 0, 7 going through that, okay? Remember, it has to be, it makes a 90-degree angle. Whoops. Right, 90-degree angle. So if you do it visually, you can probably pull out the answer without doing any actual mathematical work. We know it. This tangent, it's tangent to this. It passes through our line, so that means this is the center. Whatever coordinate this is, that is the center. But mathematically, what we can do, we can go ahead and just show the graph here. Using the equation y equals 2x plus 7, if you notice in our sketch on the previous page, these 2 points, your center and a vertex point that's on the y-axis, both of these points have the same y value. These have the same y value. So in your equation of your line, we're going to plug in 7 because we're trying to figure out what this x value is. Given that the y value is 7. So we plug that in, we do the math, we solve it. We can all know how to do that, and we get x equals 3. So we know we already knew the y value of the center, and now we know the x value of the center. So the center is 3, 7. And then from there, we just we can use the distance formula. Remember, you don't have to use this formula. You can just really graph it and count. Or if you know the fact that we are only going from this endpoint to the center, so from 0 to the x value, and the x value we now know is 3. So from 0 to 3 is 3 units. So the radius is 3. But if you wanted to just use the distance formula, that's fine too. And I do show it that way, but it's really not needed. Get the same answer, distance equals 3. So we know the radius, we know the center, and we just plug it in and we simplify, and that's how we get the final answer. These really aren't that tough. You just got to do it. It seems like a lot of work, but it's really not. So let's look at another one of these on this page here. So let's read it out loud. So what is the equation of a circle whose center lies on the line y equals -x plus 2 and is tangent to the y-axis at 0, 8? So it's on this line and it's tangent to the y-axis. So if you're tangent, you're tangent to the y-axis, right? No matter which quadrant you're in, you're going to go left or right to get to the y-axis. So based on the information we have here, what is the center of our circle for either the x or the y? Which one do we already know? So if we have a point and you are going to the y-axis, we already know what the y value is. So the y value is 8. So in this problem, let me just go ahead and write down, based on this, we know, we don't know what x is, the h value, right? The center, the h. But we do know that the y value is 8. And we don't know what the radius is yet. So that's what we know right off the bat, based on that it's tangent to the y-axis. So wherever wherever our point is, let's say our point is like here, right? To go to the y-axis, this point, and so this point and this point have the same y value, which is 8. And well, we know that's going to be 0, 8. But we know the y value of the center. And remember, this is our center. This is h, k. By the way, my graph is definitely not correct. And even if we didn't know it was in quadrant number 2 and you thought, I'll just put it in quadrant number 1, it doesn't matter. Just a sketch of, it's somewhere over here and we're going to the y-axis, so we know that's true. So then from here, in your equation, to find your x value of this, all you have to do is plug in 8 into the equation for y. You plug in 8 here, and then you solve for x. Everyone quickly do that. I'm going to give all of you 30 seconds to plug in 8 and solve for x. Guys, like anything in pre-calc, this takes practice. Some things seem harder at first than they really are until you practice them. The learn module, practice module, going through these recordings again, working out the examples. All right. What did everyone who were able to finish get for the x coordinate? -6. Yeah. And then if you know that is -6, that means the radius is what? What's the radius? The radius is 6. Yep. Yeah, because from 0 to -6 is 6 units. Yep. Let me just show that work on this page. There's the actual, what it really looks like on your graph, if you're wondering the exact. Yeah, we plug in 8 for y because the center and the tangent point have the same y value, just different x values. So you plug in 8 to find out what is that x value on that line. And a lot of you said -6. So that is the center of your circle. And then, you really don't have to show any math because from 0 to -6 is 6 units. So this part showing the distance formula is overkill. Do not need to do it. I'm doing it just for fun. And you get 6, of course. And then you just plug everything in and you get the answer. All right, so that was the last example, guys. Really go through your modules. You need to go through the modules for day 2 and work out all the examples for the learn and practice. You don't have to read about it or learn from the modules. Just do the examples and check your answers. And I know I say this a lot, but you wouldn't believe the emails I get about people not doing well on quizzes. They want more opportunities than the 3 that are given to them. Guys, the quizzes aren't practice. The quizzes are to test after you have practiced by going through the examples and the modules. I hope that's clear because I'm looking at, I've been going through a few of you, and I see some of you aren't visiting the modules at all, or you spend like a total of 10 seconds, which I know is not enough time to even write down the examples. So, all right. Well, it's about that time. Let me just go back to the one that we skipped. We did skip one of them. We skipped this one. So go ahead and quickly write this one down, and I'm going to show this answer real fast, just so you can have it. This was actually pretty easy, right? I'm trying to figure out where on my screen I put my white boxes. All right, here we go. So I'm going to quickly show the work. You may want to not watch this part and watch the recording later to actually kind of unpause as needed to get this answer. But that is the answer to this example. But it's about that time. So I'm going to call it, but make sure you practice, and hopefully I see some of you this afternoon. If not, not a big deal. Remember, the day 3 of circles you can always watch next week on Tuesday. I would say day 3 is probably the most complicated. Well, I don't know. Some of you might think it's easier. Personally, I don't like using midpoint formula and distance formula. But yeah, we don't do that on day 3. So I'll let you decide if you think it's easier or harder than day 2 of circles. All right, everyone. Well, thanks for coming. And as always, I hope you learned something. I will see you all later.